Hey guys, this is your video for your Chapter 15 study guide all about solutions. I'm going to be kind of talking through most of it unless it's math or graph related, so you're going to have to listen and pay attention, but it'll all be the same. So for number 1, describe the characteristics of solutions and identify the various types. Some characteristics you could talk about was that they can exist as solids, liquids, or gases. Most solutions are liquids. Water is the most common solvent amongst solutions. And then some substances readily form solutions while others don't. It just depends on whether those substances are soluble in each other or insoluble. For number 2, define solubility and identify the factors affecting it. Well, solubility is the maximum amount of solute that will dissolve in a given amount of solvent at a certain temperature and pressure. So the things that affect it are going to be temperature and pressure. Number 3, if a seed crystal was added to a supersaturated solution, which we observed in a demo in class, what type of solution would the end result be? Well, when we put our seed crystal into our supersaturated solution, you can see that the excess solute precipitates quickly, very quickly. And so the remaining solution is just saturated. The stuff that will readily dissolve at that temperature stays in there. So it's characterized as saturated. For this section, using the graph to answer these questions, it says, what mass of solute will dissolve in 100 milliliters of water at the following temperatures? Remember that 100 milliliters of water is the same thing as 100 grams of water because 1 milliliter is equivalent to 1 gram. I put it up on the board for the unit, so should be able to remember that. So we're looking at potassium nitrate at 70 degrees. And so all you have to do is go to 70 degrees on your graph, follow it up to potassium nitrate, and you're going to meet it right there. And so it says what mass of solute, and so over here on this side of the graph we're looking at grams of solute, so all you have to do is follow it across, and you'll see that your answer should be 130 grams. And you just follow that same procedure for the other two, and if you do that, you would have seen that sodium chloride would be about 40 grams at 100 degrees Celsius, and ammonium chloride would be about 70 grams at 90 degrees Celsius. And then which of those three substances is most soluble in water at 15 degrees Celsius? What I did was I went to 15 degrees Celsius and then I just put a dot on each line that I met. So right here is KNO3, so that's not it. And then I met up with, let's see, KCl is right there, but that's not one of them. And then you come to this spot, that's ammonium chloride, so that only leaves us with sodium chloride. And so for number 2 on this section, what mass of solute will dissolve in 200 milliliters of water at the following temperatures? Well, this is per 100 grams, and so if you double that amount of water, then you're going to double the amount of solute that can dissolve. So for those blanks, you're going to double the amount that you saw in number 1. So for A, it's going to be 260 grams, B is going to be 80, and C is going to be 140. Down here on part 2, on a solubility curve, the lines indicate the concentration of a blank solution, one that has the maximum amount of solute that will dissolve. Well, we talked about that several times. One that has the maximum amount of solute at a particular temperature is going to be a saturated solution, saturated. And then the values on the graph, and then you decide which word to fill in, below, above, or on a curve, represent unsaturated solutions. So if the saturated ones are on the line, then below the line is going to be unsaturated. So your answer is going to be below. Alright, for this we're going to use the solubility curve on the other page to label these solutions as saturated or unsaturated. And then if they're unsaturated, write how much more solute can be dissolved. So what you do is you go to the graph on that page. For instance, the first one is a solution that contains 70 grams of NaNO3 at 30 degrees Celsius. So we're going to go back. And so I'm going to go to 30 degrees Celsius here and meet up at 70 degrees Celsius. And so that is this dot right here. But NaNO3 line is clear up there. So I've got all this distance before I make it saturated. So that means that my answer is going to be unsaturated. I'm just going to write that. And then how much more solute can be dissolved, I just kind of look at the difference between where my dot was and where the line is. And what I came up with is about approximately 35 more grams. And then for the rest of these, when I looked at them, this one was saturated. It was right on the line. This one is saturated right on the line. But this one came in below the line, so it's unsaturated. And then approximately 60 more grams could dissolve in it. Okay, the difference between a solute and solvent. The solute is the one that dissolves, and the solvent is the one that does the dissolving. Solvent is always present in more volume. The difference between saturated and unsaturated. A saturated solution contains the maximum amount at that particular temperature and pressure, while an unsaturated solution could possibly have more solute added to it. There's still more room. What does it mean if two liquids are said to be miscible? It means that they dissolve in each other. What are 3 ways to increase the rate of solvation? Well, that would be things to speed up dissolving, essentially. So you could stir the solution, you could heat it up, or you could increase the surface area of your solute. Number 10, why are gases less soluble at higher temperatures? If you increase the temperature of a gas, fast-moving particles are going to become even faster moving. And so you increase the kinetic energy, meaning they want to escape out of a solution. For number 11, distinguishing between a dilute solution and a concentrated one, this is the best explanation that I know of. So I've drawn 2 pictures here, a dilute and a concentrated. And a dilute solution is one where there's less solute per volume of solvent, and a concentrated one has more solute per volume of solvent. So you can think of it that way, or you could put a